Welcome to our college algebra. Today I will teach you exponential and logarithmic function. I will divide my class in two sections. The first topic is natural logarithms. Natural logarithm. What I mean natural logarithms? Natural logarithms is written in this way. So this is the symbol, natural logarithms. So logarithms x. Okay, that's the symbols. Okay, so these are logs to the base. The base e. Okay, the base e. Okay, that's very important. Another thing, the number e. So this number, the number e. So this symbol means is an international it's an irrational number. All right. You write the number in the like e is similar to this number. It's equals 2.718 28. Okay, this is the meaning this meaning e. All right, so this which occurs all right. So this is very important. Understand what I mean. This is actually the concept, natural logarithms. So you see the symbol like this, natural logarithms of x. So are logs to the base e. So the number e, this number e is equals 2.71828. Okay, this occurs in many practical applications, in many problems. All right. So this is the main concept or class. Okay, next let me talk about the theorem. This theorem talk about if, for instance, if x is you have x is any positive is I will to write this theorem. Okay, and if only if A and B A and B are a positive numbers, positive real numbers. Right. Also, another clue: A must be different of B. Okay. I mean, let's A different to 1 and then B different to 1. Different to 1, okay? So this is, I think, the main so then we have this, look at this problem. I want to develop this to log, for instance, log with the of x with the base 8. This is equals, will be equals log x, log of x with the base b right here, divided by log of a with the base b. Okay, so if we write it in a different way, we will have a log of x with the base b equals log of a with the base b right here. To the exponent, we have a log x with the base 8. All right? So if you simplify, we will have log of x with the base b equals, open parenthesis, you write the parenthesis right here, we will have a log x with the base 8 times with a log of 8 with the base b. All right? So then as a conclusion, we will have here log of x with the base b equals, so it's a division here, log of x with the base b divided by with a log of 8 with the base b. I mean, this main, we started with this problem, so the conclusion must be the same, okay? So that's it. Let's go and let me show you one problem here, applying with the natural logarithms. How work with the natural logarithm. So let's go to the example. Let's write a natural logarithm of 0.427 equals so open parenthesis here, we will have 2.3026 times log, so log 0.427. All right, so next step here, we will have just multiply here 2.3026 times log, so the natural log or log is negative, this is equals -1. All right, -1 plus 0.427. Now here, we here we have to understand we have the 2.326 times -1 here. Now plus we have to add 63 here, 0.6304. Okay. Now here, yeah, just bring down 2.3026 times -1 times I mean added here point 85, 10. It's no, not here. It's a mistake. It's not this one. So we have 2.3026 times point, yeah, 36, 3696. We added right there. So negative. This is negative. Here we have negative there. Okay, then if we will have natural logarithms of 0.427 is equals, when you multiply this, you multiply here, we have multiplied this, then we will have this times in use the computer, we will have negative in negative 0.8510. I am using my my cell phone to make the division and the multiplication, all problems here, because it's very hard to develop an all problem. It's long process. Okay, so that's it. I think that's the right answer. Let's see another example. So I get some confused in this because it is hard. Use the technology to find the answer here. So let's go to solve another problem. So check your operation in your cell phone and your computer or on your machines on the computer. You get it. Try to get it. That is right. It's fine. Natural law. It is okay. So let's go. Write another example. Let me write find problem. Find the log of 27 with the base 5. Okay, we have this theorem here. It's easy. This theorem, it says use the same one. Here we have 8. Let me write the 8 equals 5, and then x equals 27, right? The numbers right there. So now just use the formula right here, log. Just write it, the log of 27 with the base, log with the base 25 with the logs 5 is equals, will be equals here. Oh, 27, not 25, 27, yeah, 27. So log, with the, what is the base this? What is the base 10? Base 10 is 27. Divided by log of 5 with the base 10, right? So this, you solve and use your computer. In the top, you will have 1.4314. All right, check in your machine. So in the bottom to this is equals 0.6990. Okay, so if you make this division here, you will have 2.05. All right, check it. Use technology. Remember, right now I don't want to stop to do the whole process in each operation. It's too hard. It's too long. Not hard. It's very long. It takes a lot of time. So let me do another problem here. Okay. So find here, find natural log of 47.2. So here we can let x, in this case, x is equals 47.2, all right? Just give it the values. Now, how much say a is equals, in this problem, equals e, all right? So, and give it the values, and b is equals 10, is the base 10. So if we use these values to solve, we will have natural log of 47.2 equals log of 47.2 with the base e right here, base e is right here. Okay, you have the value there. So this is equals the log is the base 10 of 47 here, 47.2 divided by log e with the base a. All right, see? So now simplify here. Let's try to write natural log right here of 47.2 equals, let's write here log 47.2 divided by log 8. See? So remember the value of log e, okay? Log e. So since remember the value I give it at the beginning of my class, e is equals 2.718, whereas 28, right? So now we are able to calculate it, the log e by interpolation. So then we have log here e equals what is 43, right? Log e is equals 0.4343. See, check it. So I will erase the process to continue to finish. So we are here. Look at this. We are here. Keeping in mind right there, I will erase the top all data right here to continue with the problem. So this is the first part of the problem. So we are there. We are here. So that's C. Just write it. Natural log 47.2. I write it again. So equals. We have some information right there. Log 47.2 divided by the number. Right now we know how much is C. How much is C? 43. All right. So now, since look at this, I going step by step because it's confused. You don't follow directions. Just write 1 divided by 0.4343 If you divide it, this is also 2.3026. See? I mean, this. So becomes, I will erase this now. We don't need it. Just write it natural log 47.2 equals 2.30 26 is this number right here times log 47.2. All right, so if you multiply those, we will have here 2.3026 times the other side. We will have a log of this number is equals 1.6739. So doing your calculator, use calculator, and then you simplify this. I mean, multiply, you will have 3.85, 43. See? So now exactly you have, we can, so here you want it, we can able to prove the next answer. So natural log of x is equals 2.3036, I mean 26, not 36, times log x. All right, that's it. This is the complete solution or natural logarithms. Okay, I solved a couple of problems to explain it, what I mean, how to use the natural logarithms. It's not that complex. The operations are a little bit big, complex, but you use your computer or your cell phone, or your machine to multiply or make operation is easy, very easy. Now, the next section, I will talk about the exponential. So this is section 2, exponential. So exponential and logarithmic. Equation. All right, exponential and logarithmic equation. All right, to do this, we have this theorem. If, for instance, if we have x greater than 0, and then you have y greater than 0, and then b greater than 0, and also b different of 1, then x equals y. If, only if you have the formula here, log of x with the base b equals log y with the base b. Okay, that's the condition. So this is this theorem work with the, keeping in mind this theorem. Actually, is the definition, the concept for this second section. All right. After this, we have an example. I will solve this example. So solve the equation. We have 7 to the x power equals 12. All right, this is our problem. If we take here, if we take the base 10, okay, the base 10, we will have, so our problem right here. So let's write log 7 to the x power. It's very simple. This section is very easy. So we will have log, this is equals log 12. So this is in the way to write that problem. So here we have x log 7 equals, next step is log 12. So then now we will have x equals, just solve the problem. So log 12 divided by log 7. See? So now to get the decimal, we can write, so here, it's also not exactly, but it's also the most closer. We will have x equals, so log 12 divided by log 7. So try to find the answer right here. How much is log 12? So it's equals 1.0792, right? So log 7 is equals 0.8451. Okay, so then you divide it, this number, make a division, will be equals 1.3. 1.3. So that's it. That's the answer to this problem. Easy, right? It's not hard. It's very, very, very not complex. It's not complex. Let me show you another problem. It's very it is very simple here. So example. It's another problem. Let's write solve 3 to the 2x minus 1. Okay. Equals 4 to x plus 2. So that's it. That's our problem right there. So now we have to take the logarithms in both sides. We have to take the logarithms in both sides. See, remember, I don't want to write the process right now. Just write the problem. So write log right here of 3 2x minus 1. Okay, in both sides. So get the logarithms in both sides. So log 4 to the x plus 2, right? So get the logarithms, or in this case, or write it here 2x minus 1 log 3 equals x plus 2 log 4. log 4. Either one. Okay? So here we move it to the here 2x log 3 times log 3 equals x log 4 plus log plus 2 here plus 2 log 4. All right. Okay. Or then the other way, you must to write, or you are able to write 2x log 3 minus x log 4 equals 2 log 4 plus log 3. All right? So here, what is the common factor? So the common factor here is x. So since the common factor is x, of the left member is x, here, right here. So we have then x, right here, x, right here we have, I'm talking about the first factor. We have the common factor x, so we are able to write it 2 log 3, right? Minus log 4, right here. The other side, we bring down exactly the same thing, 2 log 4 plus log 3. All right? Got it? Step by step. So, or as conclusion, actually, we will have x here equals, just write it 2 log plus log 3 divided by 2 log 3 minus log 4, right? So we are here right now. I will erase the top to continue to find the answer. Almost done. So let me check right here. Right here, not finished, almost, but we are right here. So I will erase the top. So let me write it over there. Using the properties of the logarithms, we have to use the properties of the logarithms right here. We have to able to remember those kind of rules, the properties of the logarithms. So you have the problem right here. Let me write it x again right here. So log 16. So remember, we have right here log 16 plus log 3. So remember, using the properties of the logarithms, in the bottom log 9 minus log 4. All right? Or finally, we will have x equals conclusion log. What is the answer here? Log 48. Remember, we have to use the properties of the logarithms right here. So divided by log over of 9 divided by 4. So this is our answer, the correct answer, and this problem. All right, got it? See, check it. Let's write another solve another problem, easy one. I will solve some easy problem. Let me write another simple problem. Let's write example. So we have to solve that's our problem, okay? Solve log of 3x plus 2 plus log of x minus 1 and then equals 1. All right, so now just try to identify. So since so 1 here is equals log 10. All right, identify those numbers. So we have now, we will have, let's write right here, log of 3x plus 2 times x minus 1, right, equals log 10, right? So multiply right here 3x plus 2 times x minus 1 equals, 10, right? It's simple. Now we will have here, you multiply these binomials, two binomials, we will have 3x to the second power minus x minus 2 equals 10. Yeah? So now continue 3x to the second power minus x minus 12 equals 0. I move 10 to the left side, right? Negative 2, this is positive, you move it over here, is negative 10. All right? So now if we have a quadratic equation right here, see? Quadratic equation. If we have a new quadratic equation right here. So how solve the quadratic equation? This is a quadratic equation. We have to use, we will have here, I will write it, x equals, remember the formula for the quadratic equation? We have to use, just write 1 plus minus the square root. Remember the formula? It's 1 right here plus 144 there. I skipping some step. I don't want to use all the step right here because I don't have a space right here. But you guys, you understand, right? You must. I don't want to solve all problems, all the step. You need to practice and then see why get this answer. So 1 is x in one side. We will have 1 plus the square root. The square root is 145. See, divided by 6. Or the other side, we will have x 1 minus, because it's negative a square root 145. 45 divided by 6. See? So I want actually that's the answer. This is the answer. So I'm going to explain something. That's the answer, okay? But let me explain it why, or something here about why I get it this answer. If for instance, if x is equals, in the first, this one 1 minus square root 145. So divided by 6, then x minus 1 is less than 0, right? Some clue. And another thing, and so log of x minus 1, look at this. So here, this is not exist. It's not here, right? So hence, so then what is must to be the right solution? And the only solution what is what is the right solution? I will erase it right here. This right now is x. The solution to the problem is 1 plus square root 145 divided by 6. It's not good. Right there. This is our solution. All right. To our problem that I wrote before. Okay. So that's it. Exponential and logarithmic function. We show you how find the natural logarithms and then also how solve problems with the exponential and logarithmic equation. So that's it for today. Thank you so much. Thank you.